Hi, welcome back. We just started our series on sets and operations on sets, and now we are at a very subtopic called operations on sets. And we said we have three types of operations on sets. We have intersection, we have union, and we have complement. The last recent episode was part 10, where we dealt with intersection of sets. Now, in this very episode 11, we are dealing with disjoint sets. Without further ado, let's hit the ground running. Now, what are disjoint sets? For example, if this is a disjoint set, right? If no member of a set A belongs to B, then the sets A and B are disjoint sets. In particular, if A and B do not intersect, then they are disjoint sets. For example, if P has members of 2, 4, 6, 8, and Q members of 1, 3, 5, 7, then P and Q are disjoint sets since no member of P belongs to Q. That is, P intersection Q is equal to null sets. This symbol means null set, no member in that particular set. I hope you remember our previous lessons. So the recent episode was talking about intersection. Intersection means set A and set B has common members, which we can list them. For example, example was like this. In the intersection, you see here, A has its parts, B has its parts, but 1, 2, 3 are intersected, right at the middle. So that is it. But here it's just directly opposite. It means that no member is appearing here and here. So it means that if you should draw a Venn diagram, there's nothing of this sort, like intersection here. So no member appears here. That is disjoint sets. It's as simple as that. No member can be found here. That is why we have this symbol as a null set, null symbol. Now let's go on with some operations. Now let's continue. Here we can see here, similarly, we are dealing with operations, typical examples. So similarly, if set X has members of 1, 3, 5, and Y also has 2 and 6, all right, these are disjoint sets since there are no common elements, and so X intersection Y is equal to a null set. Disjoint sets are said to be mutually exclusive. Now, this is one of a mathematical expression that confuses a lot of people. When we say set or things are mutually exclusive, it means that one does not depend on the other. Everyone has its own power. Each of them can act autonomously. I don't depend on you to operate. You don't depend on me to operate. We are independent. You do your thing, I do my thing. So that is what it means. So when we say disjoint sets, it means that these two sets do not have to agree on anything to operate, right? Because if you check a 1, 3, 5, if you come to Y, 2, 6, none of the members is appearing here or there. So this means, or simply put, they are disjoint sets. Now this is representation. We have A, we have B. You see, there's nothing crossing or intersecting, drawing over, overlapping, whatsoever. It's as simple as that. So I think this is one of the simplest operations on sets. So we will see you in the next episode. Stay tuned. Step boldly into the math whilst you like and help us hit Operation 1K followers to start life. See you soon. Ciao.